Hey guys, this is April 13th, and this is Faith Christian's Algebra 1 class, and we're starting Chapter 19, Chapter 9, which the entire chapter is on polynomials. Today we're on 9.1, where we're classifying and evaluating polynomials. So I am going to attempt to do this standing up, but I am also pre-recording this. So if I disappear from the scene and I don't get back up, do not call 911 or alert anyone, because I filmed this like a week ahead of you watching it. So we'll just get through it. Trust me, I'll get back up. We'll try to figure it out. So if you turn to 9.1 in your book, that's on page 370, and we're going to start out with some lesson openers. All of these things that you've done in this chapter, you probably did in maybe just a weensy bit in 7th grade and then a wee bit more in 8th grade. So it should seem somewhat familiar to you, but we're just going into a little bit more detail. So let's just start with some lesson openers. And these lesson openers are mainly for you to figure out, what do they call it? Terms and like terms, so we can get into polynomials just a little bit further down when we get into our definitions. So behind me are lesson openers, which has a smidgeny of a glare, so sorry about that. So my first lesson opener is we have x plus 2x, and if you remember, we're combining like terms. What makes the term like? What makes the term like is the x. And I can go ahead and simplify that, or I can put those together. That's what simplify means. And that's simply going to become 3x. So that becomes 3x. This was two terms. This was a term. That was a term. Then I simplified by combining like terms, which is x, and got 3x. Now, what's this telling me to do? This is normally the thing that messes up algebra kids so poorly. And remember, I told you all the time, you need to watch this. This is called distributive property. Because most of the time, kids know to multiply 7 to the x, but they forget to multiply 7 to the 9. So let's go ahead and do that. So if I multiply 7 to the x, it becomes 7x. We're simplifying, okay? Multiply 7 to the negative 9, it becomes a negative 63. Once again, here I have two terms, just so we can go over some things, just to get the language back into your brain. That's a variable. These numbers are called constants. Since 7 is being multiplied to x, that's a coefficient, okay? Now let's move down here. Once again, I'm simplifying. Simplifying means I'm combining like terms. So I have a 3x minus 4y plus 8y. X and y are not like terms, so the only things I can combine are the y's. So if I add a negative 4 to a positive 8, or that would be basically signs aren't the same, so I'm going to subtract, take the sign of the larger number, and so that would become 3x, and that's going to become a positive 4y. So you got that far, right? And then your last step that we're going to do, some of them I haven't done, but let's look at what's happening right here. Here we've got that wicked distributive property, again, that tends to throw people off. I'm going to go ahead and multiply 3 to the x. It becomes 3x, so x now has this literal term or variable has a coefficient of 3. I'm going to multiply 3 to 5. Now I have a constant of 15. Look what's happening here. Remember what happens here? You can kind of think like there's a little negative 1 right there, which is going to adjust everything that's inside this parentheses. So let's just pretend there's a little negative 1 there. Negative 1 times 4x becomes a negative 4x. Then that negative 1 times the negative 2 makes it a positive 2. Now I'm going to combine like terms. So my like terms are the x's. So I have a 3x and a negative 4x. If I'm adding those together, the signs aren't the same. So I'm going to subtract, keep the sign of the larger number, which is the negative 4. So now I have a negative x. Then I'm going to combine the two constants, or the two numbers, which is 15 plus 2. and that's going to become a positive 17, and that's all I can combine. All I can combine is that right there. That's to get your brain back into what you've done in the past, and it also tends to be some things that you all tend to struggle with. My eraser is way over there, but I'll get it back in a minute. So let's take a stroll down this board and let's start discussing polynomials. I've written a few terms on the board, but you, of course, have your lovely book right there in front of you. And I need my stand, if I can get it. I did not fall. I was just getting my stand. So let's look at what we've got going on. So you have done polynomials before. A polynomial is an expression that can be written as a sum of terms consisting of constants and variables with non-negative exponents or products of a constant and one or more such variables. Then they start to go over things, like what's different types of polynomials. I have a monomial, which is exactly one term. And we can go over back to our lesson thing that we've got today. And we come up with 3x after we simplified. That's one term, that's a monomial. Then we've got binomials, which is two terms. Now you're adding or you're subtracting these. So look right here. We have two terms. We basically have a constant and we have a coefficient with a variable. So that is two terms. We do not have a trinomial over here in our lesson opener. Then if you go to the polynomial, it's exactly three terms. If you go over three terms, then we just call them other polynomials. We don't go through quaternions or something else with 5. So going on through there, let's look at your table, just so you can kind of read what these things are. So if you look at your table, they've given you examples of monomials, they've given you examples of binomials, and they've given you an example of trinomials and then some other polynomials. I want you to concentrate on the paragraph that's right underneath that table because it's telling you something really, really important. It's actually kind of explaining what it said up here when it said variables with non-negative integral exponents. What does that mean? Notice that this expression, so if you have an expression that looks like this, 1/2 x, that's a term. It could be included in a polynomial, and that is perfectly fine. That's because, 1/2 is a constant. That's great, that's perfectly fine. If you had a term that looked like this, that's perfectly fine as a term. It could go into a polynomial. That's wonderful. That's great. But then look at what their next thing they talk about. What if you have something that looks like this, where I have x squared divided by y cubed? They tell you right there that would not be, if you have something that looks like that, that is not going to be in a polynomial because what ends up happening is that this would end up being a negative exponent. If there's an exponent as the divisor, then technically that's a negative exponent. You learned that in chapter 8. That's why we had to get through chapter 8 before you could really start doing this polynomial chapter. So that would indicate a negative exponent because it indicates a variable divisor. I want to say advisor for some reason. So thus, it cannot be a polynomial. Polynomials can also be classified by their degree. And when we talk about degree, first of all, you have to be able to count the degrees of the term. And then after you figure out how to count the degrees of the term, then you can figure out the degree of the polynomial. So let's look at what the degree of a term would be. First thing to know, and you can glance over at 371, you have a little billboard there. If you've got just a number hanging out, its little exponent is going to be 0. Or pretty much you just know its degree, not exponent, its degree is going to be considered 0. That's just how it be. They give you a lengthy explanation underneath the degree of term on page 370, but just if it's a constant, if it's just a number out by itself, then its degree is 0. If you got a variable, so if it's just 4, it's just got a degree of 0. If you got a variable and it's just hanging out there and it's just an x, then that's just going to be a 1, right? If you've got another variable over here, I'll make that y, and its degree is going to be its exponent. Well, let's put all of those together. What if we had 4x, y to the 5th? All those are being multiplied together. That's one term. So let's count what would be the degree of that term. I would count the exponents, or I would count the powers. My number is not going to have anything, but my x is going to have a 1. My y is going to have a 5. I combine those. I add those. So my degree for this term would end up being 6. Now, that's a term. When you're talking about the degree of the polynomial, polynomial means if it's not monomial, if it's binomial, trinomial, polynomial, it means you've got more than one term. So we have to look and count all the degrees for each one of those terms. So let's go to degree of polynomial, and I'll just go right here. So it's the highest degree of any term in the polynomial. And they gave you an example of example 1. Let me just kind of write this out really quickly. I'll grab my book so I can do it. So let's look here. This is a trinomial. And I can remember teaching 7th and 8th grade. And it was kind of, this is kind of some rules I always tell. If you're trying, because 7th and 8th grade, you're mainly just trying to figure out, is it a trinomial, is it a monomial, things like that. And they would count, I think this is how they advised them. You counted your pluses and your minuses. So you count your plus and minus signs and then add 1 to it. And that's how you figured out if it was a monomial, a trinomial, binomial. I knew I left something out. And you can look here. I've got 1 plus, 1 minus, that's 2. Add another one, and guess what? I have 3 terms. This means it is a trinomial. Now let's look at the degrees of each one of those terms. So the degree for this 3, there's nothing. That's a constant. No, nothing. The degree for this one would be 3. The degree or the power for that y would be 1. So that makes the total degree for this term 4. This one right here, the 2 is nothing. The x has a 1. So the degree for 2x would be 1. Now we go over to the negative 4x with y squared. The degree for 4 is nothing. X is 1. The degree for y is 2. Add those together, and the degree for that one is 3. Now let's read over again, what does it mean by the degree of a polynomial? It's the highest degree of any term in the polynomial. So which term has the highest degree? And that's my degree for the entire polynomial. It's this. So the highest term degree was 4. That's the highest. So that means the degree of this entire polynomial is going to be 4. So that's how you do that. If you want to read over this little table, you can. But there's another little section right here that it's not necessarily like you're going to have it on a test or you're going to have it on a quiz, but it's going to become extremely important when we start combining polynomials, because you need to learn how to write the polynomial in standard form. So I am right here. We just did example 1. It's right here. This is telling you how to write it in standard form. So basically, all the problems you're going to deal with mainly are already in standard form. So what does standard form mean? They'll give you one, and we actually have one. You're going to work with this a little bit in your homework today. So they gave you a polynomial that looked like this. But this is not in standard form. In standard form, the terms are arranged in an order of descending degrees of one of those variables. So all the variables in here are x. So descending degrees means I'm going to start with the x that has the biggest degree. And the one that has the biggest degree is x cubed. So I'm putting 6x cubed first. Then I go in order down. So right here, I put 4x squared next. The next one, I have x to the first power. That's just plain old x. And finally, I have 3, no x. That's standard form. You'll have a little bit of that in your homework, but especially as we go into multiplying polynomials and we're doing FOIL and things like that, they expect you to write your answer, to combine like terms, like we did, and to write your answer in standard form. That's just how you do it in algebra. It's just one of those things that be. So if you look at example 2 and example 3, you have done this. This is where they give you this expression and then they tell you what the values of x and all the variables are. And then they expect you to go back in, substitute those substitute the value for the variables, like if on this one, x equals 3. They expect you to go in and substitute 3 in for the x squared, substitute 3 in for the 5x, right? You're substituting the x and then computing it that way. What they've done in this chapter that you've not had in the past is that now that you've gone through the exponent chapter, you are squaring or you're cubing some of your values, and then you're figuring it out. Let me see. So, in example 2 and example 3, you do have 2 questions on your quiz that look like that. If you want to know what your other quiz question looks like, it is pretty much like this table over here on page 370. You are basically trying to say what the polynomial is. Is it a monomial? Is it a binomial? Is it a trinomial? A polynomial? Is it not a polynomial? And then you're also telling me the degree of it on your quiz. We're going to do 2 things that look like that in your homework. And I think I've written your homework down. Your homework, if you were doing this, sorry, trying to shove that out of my way. Your homework, if we were doing this in regular class, would be 1 through 39 odd. Of course, it's a weird time now, and I understand if a lot of you are trying to pick up extra chores, pick up extra work, doing different things like that during this time. Please do enough from each little section where you understand what you're doing for your quiz. That's what I'm asking. If we just glance over your homework, number 1 does it just helps you figure out your degree. But for your test, for your quiz, you have a question that looks like the work from 5 through 13, or 5 through 14, because I'm actually going to do 14 as well. Just for practice, mainly for the future, you might want to do 15 through 20, where you're practicing with that standard form, writing things in standard form, and then they're also getting you to practice by classifying what its degree and what is it a polynomial is, or what type of polynomial it is. And then finally, from 21 through really 32, that's where they're giving you a value for the variable. You're going back in and you're inserting that value, and then you're trying to determine what the total value is. So from 21 through 32, I guess all the way down through 36, you are coming up with one number that's your answer, because all of those variables, you're inserting a value. They're telling you that. So I have a couple of problems here that I want us to just work on together. This might actually be a shorter math lesson. We'll just have to see. So I'm doing number 5. I have number 5 right here. So number 5, if we look at your instructions are so important. Classify each expression as a monomial, a binomial, a trinomial, or an other polynomial, or not a polynomial, and then state the degree of each polynomial. So let's look at this right here. So if I have two terms, all right? Because remember going all the way back to 7th and 8th grade? Ooh, 1 plussy. That, you add 1, that means 2. Here's a term, because something has to be combined. So that is a binomial. And then I'm going to come up with the degree of this polynomial. And first of all, I'll look at the degree of terms. So if I look right here, I have a 4, no degree. Then I have x, that's a 3. Then I have y to the 5th power, and that is that. So I add that, and this whole term has a degree of 8. If I look here, 2 has no degree. The x has 1. The y has 1, which has that term has a combined degree of 2. So what I do with my binomial is I go back and I think, what is the degree of a polynomial? It's the highest degree of any term in that polynomial. So the highest degree of this entire binomial is 8. So I'm going to put, that's a binomial, and the highest degree I have is an 8. And I just checked the book. That was fine. So the one that I wanted you to look at next is number 9. Number 9 I've written here. So number 9, some of you, when you see a fraction, you absolutely get so fearful that you forget what you're doing. In this case, if you see a fraction, you can go, phew, because that's saying that's a negative exponent. If you got an exponent in the divisor, that means it's negative, which means, you know what? It ain't no polynomial. Sorry, I don't teach grammar anymore. Not a polynomial. So not a polynomial is what you're going to put down as your answer. Then just for fun, I wanted you to look at 14. 14 is just 23. Just the number 23. It's a constant. And for polynomials, for a degree, that is a 0. There's no degree for a constant in a polynomial. The next question that we're going to look at, that we're going to practice with, is a little further down. I can't remember what it is. It's 17. So let's look at 17. And I put a fraction in there for you. But remember, we're really not doing anything with the fraction. It's just sometimes y'all panic over the fraction. We're going to write this in standard form. And to write it in standard form, I look at the variables. And then I'm going to write them in descending degrees, or the exponents. I'm looking at the exponents with the variable, and I'm going to write my largest exponent first, and then I'm going to go down from there. So let's look. I'm concentrating on the variables. Do I have it all in there? Yeah, I do. Concentrating on the variables. The one that has the highest power, or the highest degree, is this negative 6x to the 5th power. And if you want to, you could just mark it out. Okay, I got that one. I'm done with that one. Then compare the next two x's. What's your next biggest power? It's the 1/3. Make sure you put in a plus because that's what you're doing. I'm going to add this. It's not negative, it's positive. So I'm going to add the 1/3 x squared. Done with that one. My next x is going to be the negative 4x. And then finally, I have a constant or a number, and that is 12. So that's how you write it in descending standard form. Then it asks me to do two things. Classify it by its degree. So that they're asking for that first. So if you're doing this on a test or quiz, do it in the order it says. Classify it by its degree. Its degree is what I was doing right here. What is the highest power of the term? So I look at each term, and it's this one right here. So my highest power, or my highest degree of the term, is 5. Then I look and I'm saying, what kind of polynomial is this? Is it a monomial, a binomial, Is it, what is this? Well, this one has more than 3, so we're just going to simply call this one, call this one a polynomial. Okay, so we got that one. One that I've not written down yet, but I'm just going to scoot over here so we can do it quickly. That's our lesson opener. I don't want to get that in there. Let's do one where you have to actually insert everything in and then evaluate it. So I'm trying to look one that has a whole lot of weird things there. But, all right, the one that I just keep looking at is 23. So let's look at 23. Now, what caught my eye is 25. And 25, guys, with all those things being right beside each other, that just means they're all being multiplied together. That's a monomial right there, because nothing's being added or subtracted. But let's look at 23 because it's kind of stretched out, and you've got every single variable that's in there. So 23 starts out looking like this. So I have 2x cubed y, then I have x squared y, and then finally I have a negative 5, and there's that x, I keep losing my place, x, y, z, x, y, z, and that's number 23. Then it tells me there in my instructions, before you say I don't know what I'm doing, that quite often tells me you're just jumping around and you're not reading your instructions. It tells me to evaluate this right here when x is a 3, when y is a negative 1, and when z is a 2. Now, some of you guys are really good at trying to keep everything together in your head and doing well. This one's pretty complicated, so you might want to take the time to evaluate, put in the values for each thing, and then before you're going to have to remember, go all the way back to orders of operation and PEMDAS, because I'm going to write everything in, and then I'm going to show you where I suspect you could go wrong super easily if you weren't careful with this. So I'm going to just write down the next step. So if we do 2, and then I make x a 3, now that's going to be cubed, and then my y is going to be a negative 1, and did I leave out? No, that's just going to be a negative 1. Then, right here, x is going to be squared. My y is still going to, that's the one I think I left out somewhere. X squared. Nope, it's still a negative 1. And then I've got the 5. And then right here I have 3, the negative 1, and the 2. Let me move this down a little bit. Sorry. My board's getting kind of crazy. I don't want to see other numbers and you get confused. So what I've done is I've just gone through each one and I've tried to substitute all the variables for what it called for. Here's where I think you guys would, especially the guys who think they're really quick with arithmetic, is you would quickly go through here and try to say 2 times 3, 6, and then try to cube it. That's not right, all right? You're going to have to use exponents. You have to go through and do each one of those exponents first. The ones you could multiply all together would be this one right here, but anywhere where you see those exponents, you have to do the exponents before you end up doing some of these other things. So let's just go through here step by step. I'm going to do the exponents. So that 3 cubed is going to become a 27. This 3 squared is going to become a 9. And yes, I'm probably doing multi-steps here, but I'm just trying to show you what the next step. This was the only one that I would be able to go ahead and multiply, and that would be if a negative 5 was multiplied to a negative 3, that would be a negative 15. Then if I had negative 15 to negative 1, it became a positive 15. Then the positive 15 to the 2 would become a positive 30. So we've gone that far. Now let's do our multiplication through here. So 2 to 27 would be 54. And then multiply it to the negative 1, it would make it a negative 54. Then I have right here, 9 times a negative 1 would make it a negative 9. And then I still have the negative 30 hanging out here. Now, you do this however you want. Some people might, whoa, screensaver. Wasn't sure if you all missed some of that or not with the screensaver going on. But if you look right here, you could combine these and make it a negative 63, if you want to do that. Or if you wanted to do it on this side, you could as well. But your final answer to this one would be a negative 33. The easiest thing to do would be probably to combine those two and make it a negative 63. And then you would add that to 30. Signs aren't the same, so I'm going to subtract, take the sign of the larger number, and make it a negative 33. All right, so that's my lesson for April 13th, 9.1. And of course, this lesson was over classifying and evaluating polynomials. Tomorrow we are going to start going over adding and subtracting polynomials, which should be some review from 7th and 8th grade, hopefully, if you still remember it. So let's take a word of prayer to the Lord, and then you will be done for the day. Of course, if you've got any questions, you're more than welcome to leave me a comment, message me in Facebook, or to text me, because most of your parents have my text number, my mobile number. So let's go ahead and pray. Heavenly Father, thank you for gathering us together and helping us to learn even though we're far apart. And Father, we just pray that you'll just be with us. Help us not to be fearful. Please keep us well and help us to show others Christ during this crisis time. Father, just go with us now. Always guide us and be a light into our path. We love you. In Jesus' name, amen. Goodbye, guys. I'll see you on Tuesday, April 14th.